Welcome to the 88th video in our series about Unix tools. In this video, I'm going to continue showing you how to use Git for a simple one-person project. In this video, I'll use Git in typical ways and explain what I'm doing. But first, let's review what we did in the last video. In the previous video, we tried to update a file, but finally decided to just go back to the old version. Since we had not done a git add, it was easy, and we did a git checkout double minus and then the file name to replace the current version of file name in our working directory, which our example was factorial.c, with the version of the file name from the last commit. This time around, I'm going to show things a little bit worse. Okay, we're in the same directory. We do a git status, okay, and it seems like things are okay, and we go into factorial and we say this time is going to be different, and we decide we're gonna get it right. We're gonna get it right, and we're just going to delete all this old stuff and start fresh. How does factorial work? You have to multiply the things, and we'd like to use. Last time we tried a countdown loop, that didn't go so well, so let's try a count up loop and keep it really simple. And we'll start on 1, and we'll go up to n, and we'll increment I each time. And what are we going to do inside there? Let's think. How does this work? You have to have some product. Well, all right, and that's got to be a double. And when you do a product, you multiply, you better start with 1.0. Okay? And what are we going to do? We're going to say product equals product times double I. And that, man, how can that fail? And then when we're done, we're going to return the product. Surely. Oh. Maybe we'll try a little harder to get it right. Okay, that looks pretty good. And then we see, well, we don't really need those. It's only a one-liner. And we see this, and we say, ooh, I could be a little more efficient. Okay, there it is. Now let's think this through. The first time is a 1, and we're going to take product, and we're going to multiply by 1, and it'll still be product. It's pretty stupid to start on 1. Let's start on 2. So we start on 2, and we're going to stop on n. Oh, this has just got to work. Okay, so we do a make. And you see it was smart, and it built the stuff it has to build. Oh, we got a pass! I'm so happy about that. I just don't know what to tell you. My new iterative factorial is working great. I'm going to add that sucker before I make any more mistakes. Okay, and then I think, and then what else do I need to do? Let's see. And of course, this is an efficient, iterative way to compute in factorial. So I've fixed that up. So it's looking a little bit better, and I'm staring at this and I'm saying, is there anything else I could do, to be sneaky and make this just a little bit better? And I'm thinking, could I put the int in here? Could I get away with that? Yes, I'm on a roll. Okay, so there's stage changes, the first M, and there's some unstaged changes, the second M. If I do a git diff, it's going to show the stuff from the second M. And I just want to narrow it down to factorial.c, and it shows, yes, I can move that int into the loop because it's only used in the loop. Okay, that narrows the scope of I, which is supposed to be better. So far everything is going well because I've finally got an iterative factorial that's working, and I've tested it, and you see it seems to work. And let's see if it works in the shared library. I mean, it should, but you know, test twice, commit once. So make minus f, make file 2, and then make minus f, make file 2, run it. Yes, it passes with the shared library. And do I get status? I'm pretty happy, and I decide to I'm gonna add factorial dot everything. And it's, oh, hint. Following paths are ignored by one of your gitignore files. The factorial.o use force, blah, blah, blah. And this shows you the power of the gitignore. It prevented me from adding this one. And it says you can do it if you want to with a force, but we're not going to do it normally. So we got saved by that. So what's our get status now? And since there was no change to factorial.h, it didn't really add it, but it did add the changes from factorial.c, which we had here, and now they're all staged. And if we did a get diff, we see that. And if we do get diff cached, we see all that. And it's all merged into one diff. It doesn't show the different edits where the first time we had int at the top and then we moved it. No, it's all better now. So we've got a working factorial using iteration, so the stack will never blow up and it won't slow down. A loop is a million times faster than recursion is, and you should always find an iterative solution if you can. So far, I promised you we were going to have mistakes, but we haven't had any. Things look really good. Let's try to do something stupid. Git commit lib mylib dot everybody. And say, ooh, did not match any file known to Git, did not match. Oh, well. And again, he's smart. Because of our patterns, he says, I can't add these because they're in the gitignore file. If you want to do it anyway, you can force it. But I don't think you should. And we check, and we can see Git loves you. It has a horrible syntax. Sort of like VI has a difficult command set for some people to learn. But VI loves you, and it will try hard to make sure your data is never lost. And Git is the same way. It has a truly horrible command line interface and is very complex. But they try really hard to make sure you don't do anything stupid. And that's one of the reasons why we wanted that gitignore file. Okay, fine. So what you're telling me is, or what I might be telling you is, it's hard to make a mistake with this thing. So we don't have a README file yet. Let's add one of those. It's fairly traditional. And you could use a .txt if you were in the Windows world, but we're not going to do that. Okay. Okay, pretty boring, but also true. So there it is. We've got the git readme. We can do a git status. And we said, oh, it doesn't know readme. And, you know, we commit anyway. And you notice the README is an untracked file. It's really trying hard to warn you. How do I abort now? That should be your question. If you decide I don't want to do this. Okay, I want to go back, I want to fix it. I have an untracked file. What can I do? Well, if I exit, what happens? Aborting commit due to empty commit message. Okay, now I can add the README. And it's, remember, I gotta say status. Okay, there it is. It says I'm gonna add README because that's new, and I'm gonna modify factorial. And both of those have been put into staging. There are no unstaged changes. And so if I git commit now, what's it gonna look like? And it says new file, modified file, and everything looks good. I'm pretty happy with that. So what would be my proper commit message? It would be something like and there it is. Now, when we do a git log, you'll see, wow, I can't tell what files were changed. I could do a git diff and see it, but how about this? Ooh. And that's another reason to learn the short log, because when you do a git log with the name status option, you get short log output. And this says I added gitignore in that commit. I added README and I modified factorial in this commit. So what was that command? Git log name status. We're out of time, and the thing we should have taken away from this video is Git really does love you, and they try hard not to let you do something stupid. If you set up the gitignore file, it's really difficult to check in the wrong things. If you want to abort a commit, you can. Just don't make any changes in the commit message. So I know some of you have Git fear, but remember, Git loves you. It's hard to talk to. It's kind of grumpy, and it complains a lot. But it's doing all that because it wants to keep your data safe, keep your source code safe. And if you learn how to work with Git, Git will always take care of your data for you. So that's all the time we've got in this video. Come back next time and we'll learn more. Until then, thank you for listening.